Hey, honors geometry students, welcome back. In this video lesson, we're going to be expanding on our understanding of trig ratios to solve for all missing sides of a right triangle or of right triangles. Gotta have a spelling mistake. It wouldn't be a good video lesson without one. So you have had some introduction, I feel like a decent amount of introduction to the ratios of sine, cosine, and tangent, and knowing that sine of an angle, right, let's say theta, is opposite over hypotenuse, right? And we have to, this right triangle trig, right? Cosine of an angle is the ratio of the adjacent over the hypotenuse. Tangent of an angle is the ratio of opposite over adjacent. If you are someone that still needs to reference these, that's fine. But get yourself in the habit of maybe writing them at the beginning of each class, or writing, so it's that then you're committing it to kind of memory and it becomes more second nature. So you've also in class last time done some work with solving for missing sides. And you know that Pythagorean theorem is huge in this, right? And so actually in my last video, I started to show you how to set up those ratios. And then during class, you actually were solving them. So we are going to be using a calculator, but I'm also going to show you like, how do you do this if you didn't have a calculator? Or like, what step do I really need a calculator at? Because you don't really need one, right? We're not teaching you necessarily how to use a calculator, but we're teaching you how to set these up and solve them, how to isolate a variable. So I've actually done the first one on here for you. And so this is solving triangles. And so when I'm saying that, like that means that we're going to be solving for all missing sides and all missing angles. So in this first one, I want to talk through it, and then maybe you want to pause the video, or maybe you have this printed out. Hopefully you've got notes and something to write with. So in this, my first step is to identify, and I'll even write this. Step one, which ratio? Pick the trig ratio or the trig function. Sine, cosine, or tangent. There may be a case that there's options, right? There might be a case that there's not. So I, in this first one, chose to use 41 degrees as my reference angle. I'm never going to be using 90, never. Okay, so my next, well, I guess even actually before step one, maybe step 0, you're gonna, what's your reference angle? And then you're gonna pick the ratio. So I chose down here, number 1, to use 41 as my reference angle. In relation to that, 4 is opposite and x is adjacent. This is the hypotenuse, but there's nothing on it. It's not gonna help me. Okay, so I've set it up and I said the tangent of 41 degrees, right, equals to 4 over x. And then I went ahead and I isolated it. I chose to draw the bar here and write it over 1. Any number can be written over 1. It's like hidden math, right? If I have the number 2, it's really 2 over 1, right? Like that's there always. So you've got tangent of 41 over 1. And then I used something that we've done a lot with. Oh, I used the method of cross multiplication, right? So I did x times the tangent of 41, see that, equals to 4 over x. I'm sorry, equals to 4. 4 times 1, which is 4. In order to isolate x, I had to divide by the tangent of 41. And this seems maybe like unnatural to you because you're like, I'm dividing by a word. You're not. The tangent of 41 is a number. It's not rational. It's going to give you a crazy decimal when you put it in your calculator. But I now have that x equals to 4 over the tangent of 41. And I could stop there. Can you think of another way that I could have done this? What if I picked a different angle as my reference angle? What if I picked this one? You might be saying like, well, why would you do that? You don't know the angle measure. But you do, right? You know that A and B are complementary. So I could say 90 minus 41, and I'm going to get, what is that? 49. This is a 49-degree angle. So now what happens? This is opposite, and this is adjacent, but I'm still using tangent, right? Tangent of 49 degrees, this is so cool, equals to x over 4. Sometimes I like doing this and I like my variable to be in the numerator so that it makes me have less mistakes. When I go ahead, and it makes me have less steps, when I go ahead and I cross multiply, I end up with 4 times the tangent of 49 equals to x. Interesting. Both of these answers are correct. Let's see what happens in our calculator, right? Because this is really where we should go into our calculator. We should never be going into a calculator throughout solving these. We want to solve it without a calculator and then go into it. Sometimes when you try to use the calculator too early, that's where mistakes happen. So 4 divided by the tangent of 41. Let's do that. 4 divided by the tangent of, what was it, 41. I get 4.601. 4.601. 4.601. What was this other one? 4 tangent of 49, right? Like they don't look the same. That's so strange. 4 tangent of 49. 4 tangent of 49. Whoa, it's the same thing. Do you see how, remember they're reciprocals? So this one, instead of multiplying, you're dividing. Because remember the tangent of one angle is equal to 1 over the tangent of its complement? Do you guys remember that? We said, like, if we had a triangle, the tangent of alpha equals to 1 over the tangent of beta. I think I did that in my last video, right? Knowing that alpha plus beta equals to 90 degrees. This is some advanced math, guys. This is awesome. This is good stuff. Let's do another one. Let's do number 2. Maybe don't pause the video yet. Do it with me. And then try the next 2 on your own. That's what I think you should do. So let's see. Here's my, I'm just going to go with this reference angle. I don't feel like finding this one. I'm missing this side length, which is across the 90-degree angle. That's my hypotenuse. There's no ratio, sine, cosine, or tangent that gives me a hypotenuse in the numerator. So it doesn't matter, okay? So in relation to the 57, this is opposite. So what's opposite an hypotenuse? Sine. So the sine of 57 degrees equals to opposite 10.8 over x. Okay, I'm going to put this over 1 and cross multiply. So I'm going to get x times the sine of 57 degrees equals to 10.8. I'm solving for x, so I'm going to go ahead and divide by the sine of 57. If you don't have a calculator or you're not on your computer you're watching this on your phone or something that you can't open a calculator, that's fine. You know what? That's even better. That just means that your answer is more exact. It might not be as meaningful to you, right? Numbers, when we round them, are going to be a little bit more meaningful, but who cares? 10.08 over the sine of 57 is my answer. Okay, so if I wanted to do that in here, I could do 10.8 divided by the sine, go away. The sine of 57. Now we get 12.878 with rounding, 12.878. I want you guys to try these too. I really, really, really want you to pause the video and try them. So hopefully you've tried them. And let's see. I'm going to use this as my reference angle. In relation to this angle, this is hypotenuse, this is adjacent. Therefore, I'm going to be using cosine. So the cosine of 37 degrees equals to 11 over x. I'm going to stick it over 1. Make sure you're showing your work and getting yourself in that habit of showing your process. The cosine of 37 equals to 11. Go ahead and divide by the cosine of 37. So x equals to 11 over the cosine of 37. If you went into your calculator, you're going to have 11 divided by the cosine of 37. I get 13.773. 13.773. If you chose to use this other angle as your reference angle, you would have gotten whatever 90 minus 37 is, which is, what is that, 53? And you would have just set it up and you would have said the sine of 53, right, the sine of the complement, equals to 11 over x. Right, and when we went to go solve this, we would end up with x equals to 11 divided by the sine of 53. Right, I'd cross multiply. And those are going to be equivalent. I would get the same thing. How about this one? Right, so I really got to pay attention here. Here's my right angle. Here's my hypotenuse. So don't pay attention to how the triangle is like oriented, which way it's like sitting or laying. I'll go ahead and use this as my reference angle. So this is the hypotenuse in reference to this angle. This is adjacent. So I'm going to be saying the cosine of 60 degrees equals to x over 11. When I go to solve this, I am going to be 11 cosine of 60 degrees is going to equal to x. And I can leave it like that. I do want to show you this one in the calculator though. 11 cosine, 11 times the cosine of 60 degrees. Whoa, it comes out nicely, right? 11 halves or 5.5. Oops, sorry. 11 halves or 5.5. Interesting. These all came out as irrational numbers. So that must mean that there's something special about the cosine of 60. And if that's what you're thinking, you are absolutely right. The cosine of 60 is something special. It's 1/2. Right? It's something that we're actually going to be learning about more at some point. It's called a special angle. Right? So what would that be equivalent to? If that's special, another one that must be special, why can't I write on this right now? Is going to be, no, doesn't want me to. It's going to, the sine of 30, right? If we did the sine, I'm having some technical issues, my friends. Why is it like wonky? I can't even see the pen now. Whoa. Okay. Let me go back. If we did, I can't even find it. Okay, well, if we did the sine of 30, we're also going to get 1/2. I'm gonna go away from my calculator because I'm having some trouble. So here's what I want you guys to do. Here are some more problems for you. And I want you to go ahead and solve these. Okay, so hopefully what you've set up is something like this. Oh, not solve them. Set these up is what I meant to say. Right? You're not going to solve these yet, right? Because in this, you're actually missing an angle. Oh my, we don't know how to do that yet. So let's just set them up. Okay, so theta is going to be my reference angle. In relation to theta, I have adjacent and hypotenuse. Adjacent and hypotenuse. I like to be in the habit of labeling. So that's cosine of theta is going to equal to 4 over 5. So somehow I'm going to have to get inside there. That'll happen next week. Okay, in relation to theta, I've got adjacent and hypotenuse again. Neat. Cosine again. Cosine of theta is going to be 4.4 over 11. And even if I blew this up, even if I multiply this by a scale factor of 3 or 8 or 1/2, that ratio is going to be the same. Cosine of that angle is going to stay the same. It's a degree measure. It is an angle. That angle stays regardless of how big or small the triangle is. Here, let's see, this is the hypotenuse. Make sure you're being careful and you're looking carefully. And then 12 is going to be the adjacent. So pay attention to its orientation. Pay attention to where the right angle is. So adjacent hypotenuse, well, that's cosine. Cosine of theta is going to be 12 over 13. I could actually find the third side, right, using the Pythagorean theorem. And finally, here is my reference angle. Well, here's my right angle. This is hypotenuse. Well, I'm not going to be using that, so don't worry about it. This is going to be opposite. This is going to be adjacent. So we would say tangent of theta equals 4/13. Okay? And that is going to be, we will be learning about how do you find theta? How do you get inside of that cosine of to actually figure out what that angle might be. So what happens here? Where'd the triangle go? Well, do I need it? Right? So I'm going to be finding the angle. Notice in one, again, I don't know how to find the angle yet, so I'm just going to kind of get myself partway there. Well, in order to get there, I want to isolate sine of theta. So let's go ahead and let's multiply this by 3. Okay, so now I've got 2 sine of theta equals 12/7. Okay, I'm almost there. I'm going to isolate sine of theta. Divide by 2. Well, instead of dividing by 2, like if I divide something by 2, that's splitting it in half. So I'm multiplying it by 1/2. So I'm going to have sine of theta equals 12/14, which simplifies, right? I might as well think about that's a dilation of it, 6/7. That's where we're going to stop. More later. You'll figure that out later. But notice I'm doing trig. I'm working with trig without a right triangle. That doesn't mean that this doesn't represent, like visually have a right triangle involved. It does, right? Like this means right here that I've got a triangle. And let's say this angle is 32.4. I know it's a right triangle. It's defaulting to a right triangle. It has to be. Cosine is adjacent over hypotenuse. Well, this is 5 plus x, and this is 13. I know that. Like, that's the case for this. So if I'm going to go ahead, my goal is to isolate x. Well, I'm going to pretend this is over 1, and let's cross multiply. 13 times the cosine of 32.4, not picking up a calculator, don't tempt yourself, equals to 5 plus x. This is just a number. Relax, it's a number. I'm going to subtract 5. So I'm going to have 13 times the cosine of 32.4. I'm going to use parentheses to show that I'm ending that. Minus 5 equals x. You know what? I could leave it like that if I didn't want to go into my calculator, or if I didn't have one. If I wanted to, I would say, I'm not sure I can because this is funky. It's like real funky. Hide cursor when not moved. I don't want to highlight the clicks. There we go. Let's see if I got it now. I forgot it already though. 13 cosine of 32.4. Close those parentheses. I'll go outside of it. And then plus 5. Did I get it right? Minus 5. Back. Where's the minus? And I get 5.976. 5.976. X is 5.976. So imagine now you have that. Well, this is going to be 10.976. Oh, I can use the Pythagorean theorem now to find the other side. Oh, I can use triangle sum theorem, or the fact that these two angles are complementary, to find the other angle. And then I've got everything. I've solved the entire triangle. So cool. Okay. So let's summarize this. Let's make sure like we've got some of these things. So again, I've taken the triangle away. But you know these. The sine of an angle is equal to the cosine of its complement. The cosine of an angle is equal to the sine of its complement. 90 minus 31, what is that? 59 degrees. The cosine of an angle is equal to the sine of its complement. 93 degrees. If you need to draw yourself a triangle, do it. That is fine. If you need to picture that, well, the sine of 50, let's say this was 50, the sine would be y over z. Well, if I wanted the cosine to be y over z, I would be talking about this angle, which would be 90 minus 50. Draw yourself a right triangle. You know that this is all coming from right triangle trig. So fun question, as if all of these aren't fun. If you have cosine of A equals sine of B, sine of A, and like A is the same thing. What is that angle? Where A plus A equals 90 and A equals A. Right? Oh, 2A equals 90. Oh, what's A? 45 degrees. Doesn't that make sense? If these two were both 45, they'd be congruent. Oh, sorry. Which means that these two sides would be congruent. So it would be an isosceles right triangle. Right? And then when you switch opposite and adjacent, your sides don't change. Pretty cool, right? And finally, these two right here, this is kind of going back to what we did before. So you're not quite finding the angle, but let's say like you're not able to picture what's happening here. Right? Some of you guys might be able to picture without drawing a triangle that, well, sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. And when I'm dealing with this, I'm going to have to do the Pythagorean theorem. 5 squared plus, I'll say a squared, equals to 13 squared. 25 plus a squared equals to 169. A squared, I can subtract 25, equals to 144. Square root, a is going to be 12. So that's going to be adjacent. Okay, well now I've got it, 12 over 13. Right? If you're not super visual, you're going to be able to do that. It doesn't mean you know it better. You're just not as you just don't need the visual. Some of us need the visual, right? And we might need to see that, okay, opposite or hypotenuse, I'm going to label this 5 over 13. Oh, now I see that I have to solve for this, and I've got 12. Therefore, this cosine is going to be adjacent over hypotenuse, so 12 over 13. Right? And then similarly, I've actually already done the math for this, which is nice for this next one. Sine of theta is 12 over 13. 12 over 13. If you don't need that, it's fine. Opposite over hypotenuse. When I do the Pythagorean theorem, it's going to look the same, right? 12 squared plus, I'll say adjacent squared, equals to 13 squared. Right? This is a Pythagorean triple. 144 plus a squared is going to be 169. When I subtract 144, I'm going to get that a squared is 25, and therefore a is 5. So when I want to find the cosine of it, I'm going to get 5 over 13. Right? So just thinking like if the triangle is not in front of you, you can draw it, and it is always a right triangle. This is right triangle trigonometry that we are learning. Right? So that's all I got for you guys today. So what we did in this lesson was review some of the things that you did in class as far as solving and kind of summarize it and get more practice and examples, as well as just continuing to set them up and practicing to label and knowing that it's only right triangles and you can draw them. And if you're visual, like draw those triangles for yourself. We only did solving missing sides, but we do know that solving missing angles is coming. And that's like when we're getting something like cosine of theta equals 4/5. Well, how do I get in there? Like I want to know what theta is. And that is what we're going to be working towards next week. Don't forget that your homework this weekend is to finish up the Delta Math assignment. You have all the knowledge at this point to do the entire thing. Please remember that you should be getting 100% on all of those parts, and you can do more. We encourage you to use it as a resource. It is a great resource. You can go beyond. If there was 5 questions assigned and you got 5 out of 5, keep going, go for it. If you get 4 out of 5 and then you miss one, do another one. We want to see all of those 100% and all of those parts, all of those sections within the assignment. So other than that, thanks everyone, and we will see you all next time.